Bismillahirrahmanirrahim. My name is Muhammad Yasin, Edwards College, Peshawar, Pakistan. Dear students, today we will talk about series, the definition of the series and its types. In the last lecture, we already have discussed about sequence and its types, arithmetic sequence, geometric sequence and harmonic sequence. Today we will discuss in detail about series and its types, arithmetic series, geometric series, etc. First of all, I will simply explain the idea of series. What is series? Simple definition of a series is that series definition, simple in simple word, the summation form of sequence or progression. It is a very simple, it is a simple definition of series. The summation form of a sequence is called series. We will discuss about three types of series. First one is arithmetic series, arithmetic series. In future I will denote by AS. It means that arithmetic series. What is arithmetic series? General terms of the arithmetic progressions are A1, comma. For today we will replace comma by sum plus, and the second term of arithmetic sequence is A1 plus D, comma, but today we will replace comma by summation sign. So A1 plus 2D plus up to so on, and the last term is A1 plus n minus 1 into D, which is the last term. This is called arithmetic series because it is the summation form of arithmetic sequences. Simple, in very simple example, there is, for example, there is 1 plus 4 plus 7 plus 1 plus 4 3 there is a difference 3 difference between 4 and 1. So 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10, and it is arithmetic series because it is arithmetic sequence if we replace addition sign by a comma. So if we replace comma by addition, this is not arithmetic sequence, this is arithmetic series. So it is the example of arithmetic series. How we find the sum of these type of series? The formula for the summation in this case is Sn is equal to n by 2 to A1 plus n minus 1 into D. It is the formula to find the sum of n terms in case of arithmetic series. In this case, how many terms are there? In this case, the number of terms are 4, so n is 1, and the first term in this case is 1, and the difference, common difference in this case is, which is 4 minus 1, this is 3, and in this case the last term, which is A4, and this is equal to 10. Simply replace the value in this formula n and replace by 4, 4 by 2, 2 times of A1 is 1 plus n 4 minus 1 D is in this case 3. After simplification, 4 by 2 2, and this is 2, so 2 into 2 plus 4 minus 1 3, 3 into 3 9, 9 plus 2 this is 11, 11 into 2 this is 20. It means that the sum of first 4 term in this case is 22. Simply we can verify easily it is correct or not. 1 plus 4 5, 5 plus 7, 5 plus 7 is 12, 12 plus 10 this is 22 and this is also 22. Here is another formula to find sum in case of arithmetic series. For example, we have the result already. The general term of in case of arithmetic sequence is an, this is a1 plus n minus 1 into d. Say this is equation number 1. Equation 1 can be written as Sn, Sn stand for sum of n terms, n over 2, 2 time of a1 break in parts. This can be written as a1 plus n minus 1 into d. Here this result, this is equal to an general term. So, Sn is equal to n over 2 a1 plus, and this is equal to an. This formula is also can be used in case of the summation for the arithmetic series. Verify it's okay or not. Simply for this example, sum is 22 and in this case is also the numbers of terms are there are 4 number of terms and replaced by 4 and replaced by 4. The first term in this case is 1 and the last term in this case is 10. So, this is equal to 4 by 2 2 and this is 11 and the result is same in both case. So, simply formula number 1 and 2 can be used to find the sum of arithmetic series. What is the difference between these two formula? If the last term is not given, we use formula number 1. If the last term is given, then we use formula number 2. In this case, there is no difference, there is no common difference is given. Only the first and the last term is given. We can easily find sum if there are number of terms are known. And in this case, if there is no last term is given, not last term is given, we can find sum. So, these are the two formula we will use in case of arithmetic series. The next type of the series is geometric series. Mathematically, the definition of geometric series is if there is first term is a1 and the next term is a1 into r, not comma, there is a plus sign because it is series, not a sequences. The next term is a1 r raised to power 2 plus up to so on. The last term is a1 r raised to power n minus 1. It is the mathematical definition of a geometric series. It is a geometric series. Simply GS. If the first and the last term is known, this type of series is geometric and it is finite geometric series. If the first term is known and the last term is not known, it is infinite geometric series. In this lecture, we will discuss their formulae in case of finite geometric series and in case of infinite geometric series. So, the first case, if the geometric series is finite, first one case, finite geometric series. So, in this case some formula is Sn a1 r raised to power n minus 1 divided by r minus 1. In this case r must be greater than 1. For example, if the series is look like that, 1 plus 2 plus 4 plus 8 plus 16, it is a finite geometric series. In this case his first term is 1 and the common ratio in this case is 2, because 2 divided by 1 2, 4 divided by 2 1, and this is 2 is greater than 1. We can easily find the summation of this type of finite geometric series by the using the formula number 1. How? For example, how many terms are there in this case? The number of terms in this case is 5. So replace in formula number 1 Sn, n replaced by 5, a1 is 1, r in this case is 2, n 5 minus 1 divided by 2 minus 1, this is equal to 2 raised to power 5, 2 raised to power 5, this is equal to 32, 32 minus 1, this is 31 divided by 1. It means that the sum of the series in this case is 31. Verify. 1 plus 2 is 3, 3 plus 4 7, 7 plus 8 15, 15 plus 16 31, and this is also 31. Second case is that if the finite geometric series and there is formula is Sn is equal to a1 1 minus r raised to power n divided by 1 minus r. In this case r is less than 1. For example, 1 plus 1 over 3 plus 1 over 9 plus 1 over 27. It is clearly finite geometric series because the first term is 1 and the last term is 1 over 27. 1 over 3, 3 3s are 1 over 9, 9 3s are 27. It is finite geometric series. In this case the first term is 1 and the common ratio in this case is 1 by 3, which is less than 1. We use this type of formula in this case, formula number 2, and the last term in this case is mean an, and in this case an is a4, which is equal to 1 by 27. So simple. 2 implies that Sn, how many terms are there? 4 terms. So n replaced by 4. First term is 1 and the common ratio in this case is 1 by 3. The number of term is 4 divided by 1 minus r in this case is 1 over 3. So after simplification, this is 1 minus 1 over 3 raised to power 5, 3 raised to power 4. Simplify the LCM, 3 ones are 3, 3 minus 1, this is 2 over 3, and this is equal to 1 minus 1 by 3 raised to power 4, mean this is 81, and this can be written as this is 3 over 2. 81s are 81, 81 minus 1, this is 80 divided by 81 into 3 over 2, and this is 2, cancel with this one, this is 40, and 3 2s are 6, and 3 7s are 21. So in this case the summation of the series is 40 divided by 27. So simply I will summarize the series in which the ratio between two consecutive terms is same, which is called common ratio. This type of series is called geometric series. There are two cases: finite geometric series. Finite geometric series mean the first term and the last term is known, for example in this case, and if r is greater than 1 we use this one formula, if r is less than 1 we use this type of formula. And the two simple, this example and this example clearly verify these two formula for the summation. And the last case is infinite geometric series. Dear students, now we will discuss infinite geometric series. In case of infinite geometric series, the last term is not known, a1, a1r, a1r square plus up to so on. For example, 1, 1/2, 1/4 plus up to so on infinity. It is an infinite geometric series. So, there is a case number 3. I stand for infinite geometric, G, S means series, infinite geometric series. Simply this is infinite geometric series case. How to find the sum in case of infinite geometric series? It is may be possible or not to find the sum in case of infinite geometric series. If the given series is convergent, then we can find easily sum. If the series is not convergent, it means that it is divergent, then we can't find the sum of the infinite geometric series. For example, we know that Sn is equal to a1 r raised to power n one minus r raised to power n divided by 1 minus r. It is the simple case if the series is finite and if r is less than 1. We will derive the formula to find sum in case of infinite geometric series. How? If n is approaches to infinity and r is less than 1, so simply this terms limit n approaches to infinity. So, there is r raised to power n, this is approaches to 0. How? For example, if r is 1/2 and we replace here r is 1/2 and n start from 1, 2, 3 up to so on, replace n by 1, this is 1/2 and this is equal to 0.5. If we replace n by 2, this is 1/4. If we replace n by 3, this is 1/8 and replace by 4, this is 1/16. It means that if n approaches to largest value infinity, this implies that r raised to power n, this result approaches to 0, it is very small. Simply in case of 1, this is half, in this is case raised to power 2, this is 1/4 part. In case of power 3, this is 1/8, in case of power 4, this is 1/16. It means that if r is small value and the power is large, this result approaches to 0. So, simply this one formula is S n replaced by infinity is equal to a1 1 minus r raised to power n approaches to 0 divided by 1 minus r. So, the summation formula in case of infinite geometric series, if the summation is exists, the formula is this one, but r must be less than 1. This type of sequence is called convergent and the summation in this case is possible. For example, to find the summation of this type of infinite geometric series, so in this case a1 is 1, common ratio in this case is 1/2, which is less than 1. So, simply S infinity, this is equal to a1 replaced by 1 or r is replaced by 1/2. After simplification, this is 1/2 and this is equal to 2. It means that in this case summation is 2, because there is 1, 1/2, 1/4, these value are very small value. To sum up to infinity times, it is 1 plus 0.99 some, so this is approximately equal to s infinity, this is equal to 2. So, the series is in this case is convergent and the sum is possible. But for example, if there is 1 plus 2 plus 4 plus 8 plus up to so on, it is also infinite geometric series, but in this case the common ratio is 2 which is greater than 1. So, in this case the summation, how many terms are there? Infinite terms. Summation does not exist. It is a sample I will use for does not exist. So, summation in this case is not possible, because in this case the common ratio is 2 which is greater than 1. If we replace r by larger value 2 and replace, there is 1 2, there is 2 raised to power 2, 2 raised to power 3, 8, 16. So, series is diverging, it means that the sum is not possible, we can't control sum. So, the sum is possible if r is less than 1, if sum is does not exist if r is greater than 1. It is all about the idea of the arithmetic and geometric series and the formulae, how to find summation. Inshallah, next time we will discuss the different idea about sequences and series and its application and exercise question. Thank you very much. Allah Hafiz. Dear students, we will discuss about the arithmetic mean, geometric mean and harmonic mean between two numbers, how to find these mean. For example, if the numbers are given 1, 3 and 5, find the arithmetic mean between 1 and 5, which is clearly 3, but the formulae in this case is, it is an arithmetic sequence. First term in this case is A1, second term is A2 and the third term is A3. Clearly mean in this case is 3, but how we find formula for the arithmetic mean between two number? Arithmetic means between two number A and B is A plus B divided by 2. Simply it is denoted by A. So, in this case A is 1, B is 5, because find the arithmetic mean between 1 and 5. So, this is B 5 2, this is equal to A. So, in this case A is 1 plus 5 6, 6 divided by 2, and it is clearly 3 is the arithmetic mean between 1 and 5, and it is the formula arithmetic mean between two number. Second is how to find geometric mean between two number. So, geometric means between two number A and B is, this is G is equal to under root A B. If two numbers are given, for example A is 2 and B is 8, find geometric mean between these two numbers. So, simply replace A by 2, B replaced by 8, this is equal to 16, and in this case the geometric mean in this case is clearly 4. Third one is harmonic meaning. Harmonic mean, how to find harmonic means between two number A and B is, harmonic mean this is 2AB divided by A plus B. For example, A is 2 and B is 8. Find the harmonic mean between these two numbers. So, simply H, this is equal to 2 time of A is 2, B is 8, A is 2, B is 8. So, simplification, this is 4, 4 8s are 32 divided by 10, this is equal to 3.2. So, it is the formula for the harmonic mean between two number. This is the formula geometric mean between two number. Now we will discuss the relation about these type of formulae. Geometric square is equal to the product of arithmetic and harmonic mean. For example, we have two number, a is equal to 2 and b is equal to 8. In this case, clearly the arithmetic mean between two number 8 plus 2 10 divided by 2, this is equal to 5. In this case, the geometric mean, which is 4, already we find that the geometric mean is 4. Harmonic mean, in this case is harmonic mean is 3.2. G square mean 4 squares, so G square, this is equal to 16, and the product of arithmetic and harmonic, arithmetic multiply by harmonic. So this is A is equal to arithmetic, which is in this case is arithmetic is 5 multiply by harmonic 3.2, or it means that 32 divided by 10. So after simplification, 5 2s are 10, 2 32, this is equal to 16. Clearly geometric square 16 and the product of arithmetic and harmonic 16, it means that geometric square is equal to arithmetic multiplied by harmonic. Also clearly, if the two numbers are same, for example a is 2, b is 8, in three cases, arithmetic, harmonic, geometric, arithmetic is greater than geometric is greater than harmonic, because arithmetic mean is 5, geometric mean is 4 and harmonic mean is 3.2. It is the relation between the arithmetic, geometric and harmonic means. So dear students, next time we will discuss about the idea of the exercise questions and techniques, to be continued. Thank you very much. Allah Hafiz.